Good afternoon, ladies and gentlemen. My name is Vanessa Bauersachs. I'm an editor at European Coatings, and I have the pleasure to welcome you all to a webinar on behalf of OCSiAl. We're very pleased to welcome today Cristina Planchon and Fabio Tombolato of OCSiAl, who will give a presentation titled Graphene Nanotubes for ESD Flooring, When Color Meets Conductivity. We'll get to their presentation in a minute, but please let me shortly introduce the features of this webinar. You will, of course, receive the opportunity to ask questions. And you're very welcome to put your questions and comments in the question box in the GoToWebinar panel at any time during the presentation. I will collect them and will discuss them with our speakers after their presentation. And now it's already my pleasure to introduce your speakers for today. Cristina Planchon has 15 years of experience in the sale and distribution of specialty chemical products for the European industry market. Before joining OCSiAl, she worked for several companies such as Saint-Gobain, Owens Corning, DSM, and IMCD. Fabio Tombolato has a PhD in chemistry and over 15 years of experience in coatings and composites for different industrial applications. Since 2022, he is supporting customers in developing their projects both at the lab level and during the industrialization phase. And now I'm handing over to Cristina for their presentation.
Welcome to our webinar, Graphene Nanotubes for ESD Flooring, When Color Meets Conductivity. During this webinar, we will be explaining exactly what are graphene nanotubes. We will review together which benefits TUBALL will be bringing in the design of ESD flooring, and then I will show you a few industry-proven solutions issued by our own customers. And to finish, I will share with you a few key facts about OCSiAl for you to get to know us a little bit better. So, when we speak about conductive additives for antistatic flooring, we all know the ordinary agents already available on the market, such as conductive pigments or chopped carbon fibers. However, none of these agents will allow you to meet conductivity without giving up on some key performances. Only TUBALL will allow you to design ESD floors still being able to provide important additional parameters. So what exactly is graphene? As you might know, in 2010, the Nobel Prize was awarded for the discovery of graphene. And very little time after, we started the mass production of graphene nanotubes. This was in 2013. Graphene nanotubes, also known as single-wall carbon nanotubes, are very small particles, imagine 50,000 times smaller than human hairs. And basically, these are the 3D dimension of single graphene sheet, which rolled on themselves in one single layer, create very long and very thin particles, a bit like, spaghetti shaped, as you can see on this 3D rendering. So when we speak about very thin, think about it has the wall thickness of one atom and the diameter of approximately 1.6 nanos. In length, they are super long. They do 5 to 15 microns. And because these are carbon-based, basically they will be super strong and obviously very conductive electrically. So the key to success in whatever TUBALL-based project is to disperse these spaghetti-shaped, very thin and long particles within a target system, within a given polymer, whilst creating a conductive 3D network within that polymer, making it possible to obtain electrical properties. It is, I would like to say, it is as simple as that. TUBALL nanotubes cannot exactly be used as such within a given polymer. So to make our customers' life easier and to allow our customers to use the TUBALL nanotubes on their standard processes and with their standard equipment, OCSiAl has designed master batches of TUBALL being dispersed in given carriers. And it's the chemistry of these carriers that will allow compatibility with specific systems. So in the example that we are reviewing today, ESD floorings, to design a PU-based or an epoxy-based 100% solid floor, our customers will be using our grade TUBALL Matrix 301. TUBALL Matrix 301 is, as I mentioned previously, is 100% compatible with solid systems, epoxy, and PU. And a very important point to know about this grade is that it's 100% epoxy reactive diluent free. So no labeling EHS03. Typically, the performances, the resistivity performances that we can provide with the TUBALL Matrix 301 range from 10 to 3 to 10 to 9 ohm per centimeters. And the working dosages are very, very low. So we speak about 0.1 to 0.3% of TUBALL Matrix 301. But as if you remember what I said previously, these are 10% concentrate. So in reality, in your final system, the TUBALL loading will be of 0.01 to 0.03. It is as minimal as that. And this super low concentration will allow our customers to keep and to obtain a full array of additional benefits. What we mean by that is, for example, you will be able to maintain the mechanical properties of your ESD floors. You will keep the chemical resistance of your ESD floors, and obviously design any type of coloring you wish. So let's have a more detailed look into what exactly are the benefits of TUBALL for the ESD flooring. Here we can see very, very interesting charts. So on the right-hand side, you can see the typical results that our customers will obtain in terms of coloring by using TUBALL. As you might know, the usual target volume resistivity for ESD flooring is comprised between 10 to 5 to 10 to 6. And as it's clearly shown on this graph, the TUBALL loading to obtain this resistivity will be comprised, let's say, between 0.01 and 0.015. So the shade you will obtain will be around RAL 7042, very, very light. And on the left-hand side, you see an example of the shade you would obtain by pigmenting your final solution. Here we're giving an example in green. You can as much easily obtain any shades of reds, blues, basically any type of coloring you wish to end up with. Another very interesting chart here is showing the permanent and stable resistivity over time. As I mentioned previously, you will have this 3D network of TUBALL particles within your polymer. That means that you will be able to obtain a surface resistivity as well as a volume resistivity. And as you can see here, tested after 5 years, we are obtaining exactly the same resistivity level as when we produced it 5 years earlier. So 10 to 6 in surface to ground resistivity and 10 to 7 in surface to surface resistivity. Another important parameter for our customers is to manage their viscosity and thixotropy parameters. You remember, the loading level for an ESD flooring is of 0.1% of tubal matrix 301. This is the dark orange line you can see at the bottom of this chart, clearly proven that managing those two parameters will be more than easy for our customers. So, to summarize a little bit, what are the additional benefits of using TUBALL to design ESD floors? TUBALL Matrix 301 can be used without a conductive primer. This is a very important parameter that our customers certainly appreciate. They will be able to have a full flexibility in the base coat thickness, so very thin layers to very thick layers will be applied very easily. Any type of certification or worldwide norm can be met, such as the working body voltage test. Because of this super minimal loading, TUBALL Matrix is definitely a very cost-effective solution, and of course its low dosage makes it logistically less complex and more efficient solution to manage. I will now share with you a few industry-proven solutions issued by our customers. Here we have the case of one of our customers who wanted to launch an anti-static self-leveling epoxy floor range to protect ESD sensitive equipment such as microchips, etc. So they wanted to have a full range of resistivities to offer, from dissipative 10 to 7, 10 to 9, to more conductive 10 to 5, 10 to 6. Of course, they wanted to have a very high quality of conductivity, permanent, stable, stable in time, and to issue it in as many colors as possible. This is exactly what our customer obtained. So a stable resistivity without any hotspots. So basically the resistivity obtained in one point of the flooring through the other one is exactly the same. They could obtain all the local norms that they were looking for, and of course they were able to design it in a full variety of ranges. If I'm not mistaken, I think they had more than 15 shades available. So TUBALL Matrix 301 will allow you to design epoxy floors, but not only. And a very interesting segment in the ESD flooring market is the PU-crete or PU ESD floors. Here we have an example of a customer who wanted to design a PU concrete floor with the surface to ground resistance lower than 10 to 9 ohms. And of course, he wanted to keep this level of resistance permanent in time. This is again exactly what our customers obtain, and a very important point for them that they were able to meet is the preservation of their mechanical properties and chemical resistance. And again, they were able to vary their solution into a wide range of colorings. So to summarize a little bit, TUBALL Matrix 301 will allow you to meet any type of specification or requirement you might have attached to your target markets. So for an example, resistivity to ground of 10 to 7 ohm as DYN or ANSI. To pass the working voltage test, inferior to 10 volts, and of course all these without observing any type of resistivity degradation over time. Of course, because TUBALL can be used in a worldwide range of applications, TUBALL Matrix 301, and any other type that OCSiAl is marketing are all REACH certified, and we also have EPA for United States. Without a doubt, TUBALL will be a more sustainable performance. So if you are looking to decrease your CO2 footprint, this is definitely the solution for you. I mean, obviously, it is more sustainable because we are literally replacing tons of ordinary agents by just a few kilos. But also, this is not a product issued from mining. This is a synthesis product. So the reduced energy consumption and CO2 in production will be significant. Just think about the fact that TUBALL is not volatile. You will never need to clean your equipment after use or anything linked to, cleaning the equipment processes. And of course, because this minimal loading, another important parameter, your end products will be considerably extended in their lifespan thanks to the preservation of their mechanical properties. So now, to conclude, I will share with you a few key facts about OCSiAl for you to get to know us a little bit better. So OCSiAl is a worldwide group. We are present in more than 20 countries. We are headquartered in Luxembourg, and the TUBALL synthesis plant, main synthesis plant, is located in Belgrade. We have 3 main R&D centers located in Luxembourg, Belgrade, and Shanghai. We have more than 450 employees globally, and our production capacities are growing constantly. So much that by 2026, we estimate that we will be producing more than 120 tons of graphene nanotubes. And of course, we are very happy to share that we have more than 1,500 customers all over the world. Now, this is all for this webinar. We will go now to the question and answer session. Please don't hesitate to send your questions to webinar@oxial.com. And if you would like to receive a quote from us, please scan the QR code that you see on your left-hand side. Thank you very much.
Yeah, thank you very much, Cristina, for your interesting presentation. And actually, we have already received plenty of questions, which I would like to discuss with you. The first being, what is the color of the graphene nanotubes? Does this project affect the color of my floor coatings?
I can reply that carbon nanotubes are black in color, but since the dosage to reach the conductivity is very, very low, the effect on the final color of the coating is very limited, as already Cristina shared during the presentation.
Okay, thank you. The next question is, what type of dispersant must be used with those nanotubes?
The nanotubes, we designed our TUBALL matrix carrier to be enough to have a good dispersion of the nanotubes inside the different chemical systems. But nevertheless, during the different studies, we also study different dispersing agents that can be used depending on the different chemical systems. So we discover some dispersing agents specific for polyurethane, for epoxy, for a solvent-based and water-based system. If the customer has some specific request, they can come in contact with us, and then we can discuss this topic in a separate way.
Okay, thank you. Another viewer would like to know the dispersion method. Is it conventional or does it require ultrasonic?
No, to do the dispersion of our TUBALL matrix, the customer can use the standard equipment used for coating production. like a dissolver equipped with the cowless, or if they are equipped, they can use a rotostator mixer. We can provide to the customer guideline with all the details to perform a good dispersion in the lab in production, and we can provide a full set of let's say lab tests to check the quality of the dispersion. We have also a YouTube channel where they can also see videos related to how to perform the dispersion and how to check the quality of the dispersions.
Okay, sounds great. The next question would be regarding key parameters on load. What are the factors for the threshold to be conductive?
As Cristina showed, I mean, the dosage of our nanotubes to reach the conductivity is very low. Based on our experience in fluor application and in epoxy chemistry and PU chemistry, the threshold is around between 0.1 and 0.15 of TUBALL matrix in the total formulation, which means 0.01, 0.015 graphene nanotubes on the total formulation. We do not suggest to go lower than this dosage, otherwise there could be some issue related to variability in production process. And we do not recommend to exceed this dosage, otherwise there could be other issues, like, for example, related to self-leveling. But again, I mean, we can discuss with the customer if they have a specific issue related to the dosage.
Okay, thank you. Could you perhaps at the next question talk a little more about the range that is possible for a conductive fluor, and if a solvent-free conductive primer is mandatory?
Usually, what we know is that using our graphene nanotubes, the use of a conductive primer is not needed. So the top coat itself can be conductive enough to establish the discharge of the charges.
Okay, regarding,
sorry. Yeah.
Regarding
sorry.
the range. Sorry, if you could talk a little more about the range that is possible, that would be great as well.
With the nanotubes, it is possible to cover the full range of conductivity, so from very high conductivity to dissipative. Usually, from what we know in flooring, let's say in flooring, usually the typical range is, if they want to be ESD, like between 10.6 and 10.9, or between 10.5 and 10.6.
Okay, perfect. The next question would be, is a matrix 301 tested in a 100% UV coatings?
For a UV coating, we have a dedicated grade. I can share the name, is TUBALL Matrix 204. It's again a 10% concentrated graphene nanotubes. So graphene nanotubes are the same and 10%. The carrier is different, and it is a specific carrier for acrylic UV system, plus a dispersing agent inside that stabilize the nanotubes in a low viscous system, which are typical UV coated system.
Okay, thank you. Another participant would like to know, how does this affect cross-linking density on epoxy resins on TUBALL demand?
Based on our experience, our customer, they put TUBALL matrix on top of their formulation, so they don't need to take into consideration any effect related to the nanotubes or the carrier into the cross-linking of the resin, of the epoxy resin. Neither if they do something similar in the polyurethane. So this is our experience.
Okay, thank you. Another question is regarding copper strips. Do you actually have to place them before pouring the epoxy?
Yeah, of course. They need to create the conductive grid with the copper tapes, and then they can apply the conductive coating on top.
Okay. The next question would be, what would be the best dispersion option? A suitable dispersant will show amine or acid index.
As I said, our nanotubes, the TUBALL matrix should not require any kind of dispersant. So in principle, the customer, they can take their original formulation and add our TUBALL matrix. Usually what the customer has to fine tune is a little bit the viscosity of the system, because the nanotubes, they will create a 3D network, so they will introduce some kind of thixotropy, and usually they need to manage a little bit the viscosity. For example, moving from one thick viscous epoxy pure bisphenol A to maybe a blend of different resin to reduce a little bit the viscosity. If they need some dispersing agents, we identified some grades that we can suggest. At the moment, we never correlate the efficiency of a dispersing agent to some parameter like acid or basic, a typical parameter of dispersing agents. But okay, this is the status of our know-how.
Okay, thank you. Another question is, you mentioned that conductive primer is not required, but how does it dissipate charge without conductive primers?
Because usually the structure is like that. There is the copper tapes, then the conductive primer, and then the coating. With our nanotubes, you can do the coating that is conductive through. So basically, the top layer, of the coating will be in contact directly with the copper tape, and this will dissipate the charges.
Okay, thank you. The next question, I'm not sure if you can say about this in this setting. What is the price per kilogram of the TUBALL nanotubes? Maybe this is something.
A typical, this is a typical commercial information. I can tell the customer that the price depends on the grade and on the quantity. And if they want to have a quotation, they can come in contact with us. Our sales team will contact them and provide all the information, the commercial information that they need.
All right. Another viewer would like to know, can the CNT be used in a water-based floor coating? And if so, what would be the recommended grade? We have specific grades for water-based coating. We have one grade that belongs to the family of TUBALL matrix. The name is 302, and it is a 10% concentrate of nanotubes. 90% is a specific carrier that helps to stabilize the nanotubes in the water system. But at the same time, we have a water-based dispersion. So it's another family of TUBALL products, and so where we disperse the nanotubes in a water with the stabilizing agent. In this case, the quantity of the nanotubes in our system is 0.5%, and the name of the product is TUBALL latex, 0.5%. Okay, thank you. The next question is, what is your experience with CNT in liquid silicone rubber applications? Are there suitable TUBALL types for addition curing systems, and which amounts would be necessary for 10-6 ohm?
Silicone application, let me say that it's an application that we love a lot because our nanotubes are very compatible with the silicone. I do not have a direct experience, but if the customer is interested, can contact, come in contact with us, and then we can discuss with our expert in the topic.
Yeah, maybe that would be a good question to discuss directly. The next question would be, any advice on how to reduce foaming issues in epoxy coating using TUBALL matrix? We can provide in our guideline, we provide also some tentative formulation with a list of additives that we tested and we approve. I can also share that recently this year we perform additional testing in our lab. We did not release yet the final new guidelines, but if the customer come in contact with us, we can share the latest update and the recent studies. Yes, but we can suggest the foaming agent, yes, and deaerating agent. Great. The next question would be, is it possible to make a conductive polyurethane coating with TUBALL carbon nanotubes?
Of course, yes. We have customers that already, tested and are producing polyurethane system, spray polyurethane system. Yes. Usually, in this specific case, they use a TUBALL matrix grade that is compatible with the isocyanate part of the polyurethane, so it does not contain any reactive groups. And the customer can decide to premix in isocyanate part or either the amino part of the polyurethane system.
Okay, thank you. Another viewer would like to know, is the conductivity dependent on shear forces during production and application?
This is a good question because, as Cristina showed in the presentation, our nanotubes are very efficient, are very effective in bringing conductivity at very low dosage. But the key to achieve the properties is the dispersion. And to achieve the properties, a good dispersion is needed. it's clear that we help the customer developing the family of the TUBALL matrix. So let's say standard equipment can be used, but there are some, let's say, common rules and some tricks to use that we explain in our processing guideline, so the customer can take a look at them. But if they need additional info, they can again contact us, and then we can explain them. I can also add that in OCSiAl we can provide support at a different level. We can set a technical call with the customer, where we explain how to manage, how to process our TUBALL matrix concentrate. We can visit the customer, so we can support the customer in their lab during the lab trials, or either during the industrialization phase. And we have also a laboratory in Luxembourg where we can perform a preliminary test for the customer, for example, to check compatibility, or maybe to perform the typical percolation curve.
Okay, thank you. Another question is, are there also graphene nanotubes available for aqueous binders?
Yes, I mean, again, we have specific grades for different chemical system.
Okay, perfect. The participant would also like to know, are there any experiences for using graphene nanotubes in carpet backside coatings, having effects like anti-static carbon black?
We have a project related to this kind of application, and yes, I mean, we can share some technical sheet specific for this kind of application.
Oh, perfect. Another question would be if you can be a little bit more specific regarding water-based epoxy floor coatings, if you could talk a little bit more about this.
Water-based?
Epoxy floor coatings.
Yes, we have customers that develop a conductive system in a water-based system. In this case, I mean, they can decide to use matrix grade compatible with the component A, the epoxy system, which is typically in bisphenol A, or they can use our TUBALL matrix 302 and add in the B component, which is a typical amino system dispersed in water. So in this kind of, with this kind of system, they have the possibility to play with two different grades based on their formulation and based on what they want to achieve.
Okay, perfect. It seems like there are no further questions from the audience. Is there still something you would like to expand on or talk about in the webinar?
I think we, from my point of view, I mean, I think we touch all the most important points and most important topics. But again, I mean, we are available for any other question that will come. They can find us in the, they can find our contacts. So, I mean, we are, let's say, really open to discuss any technical project with our customers.
I just wanted to add something to the person who asked the question about silicone. Basically, exactly like Fabio mentioned, we love silicone applications because they are a bit like epoxy flooring, very, very compatible with our nanotubes. But for the listeners, you know, today, TUBALL can be added pretty much to any type of polymer that you can think of. The approaches will be different, the grades we have will be different, the carriers composition will be different to allow compatibility with the specific systems. But honestly, I think acrylic, I think even very, how to say, out of the box systems like phenolic or melamine, we can accommodate rubbers, hard silicones, liquid silicones, yeah, some PVC is also systems that our TUBALLs are very compatible with. So please don't hesitate, even if your project is not directly linked to epoxy and PU flooring, don't hesitate to send us your questions. We will be happy to respond.
Sounds great. Actually, one last question came in. TM301 versus TM207. Will the reactive diluent be removed from the TM207?
This is a topic. This is why, I mean, in this presentation, we decided to focus on 301 because the 301 is a grade that is working very well in epoxy, it's already reactive dilutant free. And but we have other grades that can be used in epoxy that does not contain reactive dilutant, and maybe we will have some news for the 2026, the incoming year.
May keep the surprise.
Yes.
Okay, actually, there's one more question rolling in. If that's okay for you to take, can you explain on the dosage of titanium dioxide content in ESD epoxy formula? It was advised not to be used more than 5%. Could you extend on that as well?
The request is for titanium dioxide.
Exactly, the dosage.
Yes, what we can say is that we know that there are some fillers that can have a negative effect on the conductivity of our nanotubes. Typically, it depends on not on the chemical nature of the filler, but on the dimension of the particles. The smaller the particles, the better they can intercalate between our nanotubes and prevent them to touch, so they prevent the conductivity. Yes, so let's say if the customer are using fine particles inside the formulation, we ask them to limit the quantity. But again, recently we tested some formulation with some specific titanium dioxide where it is possible to reach a higher dosage. So in principle, the customer can develop a lighter color without affecting too much the conductivity. Again, we do not have at the moment in the official guidelines, but we can discuss in the call with the customer. Another filler that, for example, we ask customer not to use is fumed silica, because again, it can interrupt the conductivity within the nanotubes, but at the same time, it introduces thixotropy. And it is something that works against the self-leveling. So we ask the customer to reduce, or even remove from the formulation.
Okay, thank you. And I think now this time for real, you answered all the questions. Thank you so much again for your interesting presentations and for joining us here today.
Thank you.
Yeah, many thanks also to OCSiAl for making the webinar possible, and also many thanks to you ladies and gentlemen for watching. And as Cristina and Fabio mentioned, you're also very welcome to contact them via email directly later on. Thank you so much again. Take care and goodbye.